Now let's use what we know about this definition of a log. Let me refresh your memory. B to the y equals x if and only if log base b of x is y. So using this information, let's try and solve for x. Rewrite this problem. We would have 3 to the power 4 equals x. And 3 times 3 times 3 times 3 is 81. Again, if we want to rewrite log base 5 of 1 over 125 equals x, we would have 5 to the x equals 1 over 125. Okay, let's try and write that another way. Since 125 is in the denominator, we could write that as 125 raised to the negative 1, because the negative 1 exponent means that I had a reciprocal. 5 to the x is equal to, and let's think of 125 in terms of 5s. 5 times 5 is 25, times 5 is 125. So that's 5 to the third power. So 5 to the x is the same thing as, using our knowledge about powers raised to a power, 5 to the negative 3. So with our exponential functions and our logarithmic functions, we'll learn as time goes on that these are one-to-one functions. So if 5 is equal to 5, then x is equal to negative 3. So let's look at log base x of 32 equals 5 and rewrite this. X to the 5th power is equal to 32. That doesn't look any better than what we had before. I know. Let's try and get rid of this exponent. I don't know if you've seen this before, but the way that we work with exponents is to use exponents. So x to the 5th raised to the 1/5 power. Remember, when you have a power to a power, you'll multiply. So 1/5 of 5 is 1. We'll get x alone. But if you raise one side of the equation to a power, you have to raise the other side of the equation to a power. So we now simply have x equals. But what is a fractional exponent? Remember, a couple of chapters ago we studied fractional exponents, and that meant that the 5, which is the base, the denominator of the exponent, is the index of the radical. And that means I'm looking for a number that was multiplied to itself 5 times to give me 32. And that number is 2.